Okay, now we're going to do some simplifying, and the idea here is to do this without just entering it into your calculator, so make sure that you can do it without your calculator. Your list of numbers, like your perfect squares, perfect cubes, that can even assist you on working these problems. Okay, first thing is we're going to change it to radical form, which is what we just learned how to do. So if I change it to radical form, the 32 is going to go underneath. My bottom number here is a 5, so that's going to be my root. Now, on these problems, when you're asked to simplify, it's going to be easier for you to raise the whole thing to the power instead of putting the power underneath like I was doing a while ago. So writing it this way, you would first of all do the fifth root of 32. So like I said, you can use your list of numbers to help you out. 32 is a perfect fifth power, and the fifth root of it is 2. So now we have 2 to the negative 2. Now if I rewrite this where I don't have a negative exponent, like we had looked at earlier, this is understood to be over 1, so I need to move it to the denominator, which would just leave me with an understood 1 on the top, and now I would have 2 to the positive 2, but we know what 2 squared is, so our answer is 1/4. Okay, next one. Okay, now on this one, since your bases are the same here, you can go ahead and multiply these together, but when your bases are the same and you're multiplying, you're supposed to add your exponent. So you're not going to physically multiply the 25s. I mean, this would just be like if you have x to a power times x to a power, it's still an x. So this is still a 25. Okay, so if you add your exponents, so 3/2 plus 1/2, of course you already have a common denominator, then that's going to end up being 2. So this would be the same thing as 25 to the second power, which is 625. Now, I said don't use your calculator, but now I understand with something like, 25 to the second power, but I just mean don't, enter the original problem in your calculator and just go straight to your answer. I want you to be able to do these calculations, without having to totally 100% rely on your calculator. Okay, what we're going to do here, I can't do the same thing that I just did up here by adding my exponents because my bases are not the same. But I can rewrite the 32 with a base of 2. That's going to be our first step. So I'm just going to take 2 to the 1/2 and bring it over, times. Now 32 is the same thing as 2 to the 5th power. And then that is still raised to the 1/2. So that 1/2 is this 1/2. I've just changed the 32 to be 2 to the 5th. Okay, next step is I have a power to a power right here, so my exponent rule tells me to multiply those. So I've got the 2 to the 1/2 times, and that would be 2 to the 5/2. Now I have this problem to where it's like this one right up here above where my bases are the same. So if my bases are the same, then that means that I can add my exponents. So 1/2 plus 5/2 is going to give me 6/2, which reduces to 3. So that means that I would have 2 to the 3rd power. My answer is 8. Okay, next. Okay, we have 4 to the 1.5. Okay, so a while ago, whenever I had the problem that had a decimal, we just changed it over. Of course, you may know what that one is off the top of your head. But 1.5, and if you change it to a fraction, same thing as 3/2. Okay, so I would rewrite this as 4 to the 3/2 power. Now I'm going to take that to radical form. So 4 would go underneath. That means this is a square root. The 2 would be understood. You wouldn't have to write it. And then it's raised to the 3rd power. So the square root of 4 is 2, and 2 to the 3rd power is 8. There's your answer on that one. Okay, next. Now, we worked with multiplying radicals back in the earlier section where we just multiplied what was underneath, but that doesn't apply here because your roots are not the same. And actually, you had a problem or two in your homework where I believe they just wrote down the answer was not possible because the roots were different. Now, you can do it, but we're going to have to change it from radical form to exponential form to be able to do it. All right, so if I change this over, of course here your 7's understood to be to the first power. So that would be 7 to the 1/7 times, and then do the same thing here, your exponent's an understood 1, so that would be 7 to the 1/3. Okay, so now, of course, we worked some problems just a few minutes ago like this. Your bases are the same, so you can multiply these, but you add your powers when you do that. Again, you've got a calculator that will help you out. You would have to get a common denominator of 21. So this would end up being 3 plus 7, so 10 over 21. So 7 to the 10 over 21 would be your answer. Okay, one more. Right here. Same situation that we just dealt with on the previous problem in the fact that we have different roots. Okay, so we did some dividing in the previous section, but all of those that we did the dividing with always had the same root, and these don't. So first of all, we need to change over our form. Okay, so you got an understood exponent of 1 there, understood root of 2, so that would be 6 to the 1/2 power. Okay, 36 is understood to be the first power, so that's going to be 36 to the 1/3 power. Now, I'm not ready to do anything with my exponents yet, because actually when you're dividing, you're supposed to subtract exponents, but I can't do that yet because my bases are not the same. And I had one just a few minutes ago that I had to rewrite the base. So on this one, I'm going to rewrite my 36. So I can rewrite 36 as 6 to the 2nd power. Okay, next step, we actually need to go ahead and multiply our powers here. So 2 times 1/3 is going to give me 2/3. All right, so now I finally have my bases the same. So once my bases are the same, I can subtract my exponents. So I would have to do 1/2 minus 2/3. So common denominator would be 6. So that's going to end up being negative 1/6. Okay, so we have 6 to the negative 1/6. But I can't leave that as my answer because of the negative exponent. That's understood to be over 1, so you're just going to move it to the denominator, so you have 6 to the 1/6 power. So there's your answer for that one.